Our fast-evolving world provides us with new challenges every day. Among others, it is up to researchers to develop solutions which might answer these challenges. Wireless ad hoc sensor networks enable a paradigm shift in the science of monitoring. They can significantly improve the accuracy and density of scientific measurements of physical phenomena because we can deploy them in large numbers directly where experiments are taking place. A wireless ad hoc sensor network consists of a number of sensors spread across a geographical area. Each sensor has wireless communication capability and some level of intelligence for signal processing and networking of the data. Advantages of sensor networks brings new opportunities to solve problems related to information gathering, harvesting. Easy to deploy even in extreme situations. Cost effective since we can spare wiring. Imagine a suburban neighborhood or an apartment complex with sensor nodes that monitor the water and power meters. Since all of the meters in a typical neighborhood are within 30 meters of each other, the attached radio transceivers could form an ad hoc network amongst themselves. At one end of the neighborhood is a super node, a so-called master with a network connection or a cell phone link. The sensors then pass the data along from one to another and the super node transmits it. Measurement can occur hourly or daily if desired. Sensor networks to detect and monitor environmental changes in plains, forests, oceans, etc. Scattered throughout a field, vineyard or forest, these nodes would allow the tracking of microclimates. A building manager could install nodes with sensors able to detect smoke, movement, light, etc. Although this would be possible to do with wires, with nodes it would be far less expensive. At the Institute for Industrial Communication Technologies, application-based system development is our most important goal. These applications are depending on the integrated communication technologies. An important feature of our system is the introduction of expandability in our system model. Thus, a service provider can easily add new services into the existing network infrastructure or extend the network itself. With integrated communication technologies, the interlinking of the test sensor network with other networks, that is GSM, GPRS, UMTS, etc., is possible. In this way, for example, a sensor detecting an event can alert a mobile user through an SMS or email about that event. In the same time, the mobile user can at any moment and from anywhere activate a sensor or query some specific sensors located in a given region. The demo system is dealing with the development of a basic intelligent home system, ensuring security and home automation services, from the designing of the architecture to the particular communication schemes and until the treatment of different use cases. The system is working as follows. Local area networks in the homes are deployed. The operation of the system is ensured by a special managing unit that communicates with sensors and actuators linked together through the zigbee standard-based communication technology. This managing unit handles the access rights, the location-aware interpretation of the reports, it decides about necessary interventions, it manages the communication in the network, and keeps contact with the Global Service Provider Center. This Global Center handles the management of the local area networks. It reads the received alert messages, it handles the system configuration, it participates in the delivery of services that are not possible to be provided at the local level. An intelligent home architecture has a large number of possible applications. These are several services that can easily be integrated in such architecture, but the possibilities are of a very broad scope.